Fermentation is the process by which certain types of cells can sustain ATP production in the absence of oxygen. This is connected to respiration in that it involves glycolysis. Glycolysis happens to be this process that does not require oxygen. Instead, it is instead of being in the matrix of the mitochondrion, this is in the cytoplasm, and it's really independent of the rest of cellular respiration, except for the fact that the NAD+ that's generated in cellular respiration can come back and be used in glycolysis. In respiration, the pyruvate that was a result of glycolysis, in the presence of oxygen, went through the pyruvate oxidation and Krebs cycle to produce CO2 and H2O. And in that process, we came up with 32 total ATP, although depending on the situation in the cell, we could get up to 36. In the absence of oxygen, pyruvate can be instead fermented, and fermentation results in byproducts, either lactic acid or ethanol, also CO2, and the point here is that this does not require oxygen. Still, though, we're going to regenerate NAD+ so that it can be recycled to be reused in glycolysis and continue to produce the ATP that's normally produced by glycolysis. I want to remind you of the connection of these processes in cellular respiration. Glycolysis is out here, and the pyruvate normally enters the mitochondrion, where we go through the rest of oxidation and oxidative phosphorylation. Remember that what has to come in here is NAD+, so that NADH is produced. In addition, ATP is produced in glycolysis. In fermentation, pyruvate does not enter the matrix of the mitochondrion. NADH also doesn't have to enter the mitochondrion. Instead, NADH is going to get oxidized, it's going to release its electrons, and NAD+ will be regenerated so that the cell can keep going through glycolysis and produce ATP. Not a lot of ATP is produced, but we can still keep up a sustained production of ATP in the absence of oxygen by just going through glycolysis and fermentation. One type of fermentation you're very familiar with. You're familiar with the byproduct of this type of fermentation, lactic acid. In muscle cells, your muscles will burn energy through cellular respiration, but also through the process of fermentation. Glycogen and glucose stores in glycogen can be broken down through glycolysis and fermentation to produce lactic acid, and in the same time being used to produce ATP. Lactic acid accumulation causes muscle fatigue and soreness, and if it's not removed, which it generally is, it could prevent the muscles from contracting. But my point here is that lactic acid is the result of fermentation, and that's just your muscle cells still trying to generate ATP even when oxygen has been used up. So it's an important thing to have happen, especially in cardiac muscle, where we need to keep the heart pumping and muscles contracting. Fermentation is only in low or no oxygen levels, and as long as there is some oxygen provided to muscles, we're going to get the maximum amount of ATP produced through respiration. Lactic acid is produced when glucose goes through glycolysis to produce pyruvate. The fermentation part is when pyruvate is actually reduced, so it picks up electrons from the NADH that was produced and converts to lactic acid. Lactic acid is a byproduct. The real point of this is to regenerate NAD+, so that as long as there is a sugar store, ATP can keep getting generated. So when there's no oxygen around to take pyruvate in the other direction, pyruvate will be reduced again. It was oxidized here, and now it becomes reduced to produce lactic acid, regeneration of NAD+, and a sustained generation of ATP. This also happens in other types of organisms. Here we have all these different organisms, different types of bacteria, yeast, different types of bacteria that make different sorts of byproducts that we actually find useful. You know that yeast can produce ethanol and CO2. CO2 is the bubbly byproduct of fermentation. What yeast is doing is it's taking pyruvate or pyruvic acid, it's reducing it to regenerate NAD+ and produce ATP. The yeast, when they're making ethanol, they're just trying to survive in no oxygen conditions. When people ferment to create wine and beer, they do it in no oxygen or anaerobic conditions so that ethanol is produced. Of course, CO2 is the byproduct. Other types of organisms do the same thing, but the byproduct is different. Fermentation products like lactic acid, acetic acid, acetone, isopropanol or isopropyl alcohol, propionic acid, which is used to mix Swiss cheese. These are all byproducts of fermentation, and the main goal is that these organisms are just trying to sustain ATP production through glycolysis. We just happen to take advantage of the byproducts. The advantage to the organism is the production of NAD+, which can go through glycolysis and allow it to continue making ATP to keep itself alive. The reaction, similar to lactic acid fermentation. Glucose. So we provide yeast cells with sugar in an anaerobic or no oxygen environment. Glucose is converted to pyruvic acid. ATP keeps the cells alive. Pyruvic acid or pyruvate is reduced through actually a couple of reactions to produce CO2 as a byproduct, but most importantly, NAD+. Then these yeast cells use the NAD+ to go through glycolysis again. NAD+ gets reduced, ATP gets made. And it's just this cycle of producing something that allows the cell to continue to survive, and we just take advantage of whatever the byproduct is of that particular fermentation reaction. So this is kind of a sub-story of cellular respiration. Only certain types of cells can do this in no oxygen, and it simply allows the regeneration of NAD+ and the sustained production of ATP. That allows the cell to continue to survive and do its job.